This video is about completing the square in conic sections. And here's something about conic sections so you know which kind you're dealing with. If you have a big ax squared plus big cy squared plus dx plus ey plus f equals 0, if it's a circle, a equals c. The same number in front of x squared is in front of y squared. They could both be negative. They can both be positive. If they're both negative, you would multiply everything by -1 because you'd like them to be positive. But in other words, they're both the same sign and they're both the same number. So here's an example. 2x squared plus 2y squared equal 8. For an ellipse, they are not equal, but they're the same sign. So it could be negative 2x squared plus 3y squared. Or it could, anything like that. Here's an example. Did I say different sign on my example? I gave an ellipse example. I think I said negative 3x squared plus 2y squared. No, they have to have the same sign. So here's a better example. 3x squared plus 5y squared. Same sign, not equal. And then for a hyperbola, they just have opposite signs. It doesn't matter if they're the same or not. So x squared minus 9y squared. Notice what's in front of x squared is positive, what's in front of y squared is negative. And if that's the case, the ellipse looks like this one. It opens horizontally. In other words, it looks like two sideways parabolas, each opening to the side. If the y squared term is positive, it looks like a right side up parabola and an upside down parabola. It opens up and opens down, opens vertically, it's called. So that's something about these conic sections. And now I have to find somehow where to get I guess I can reopen this. I just want to get a blank sheet here, and then show examples of completing the square. This is how you turn equations of this form, ax squared plus cy squared plus dx plus ey plus f, how you turn that into standard form so you can tell where the center is and where the foci are and what the radius is and so forth. So I'm going to give some examples. Here's an easy one. X squared plus y squared plus 3x minus 2y minus 7 equals 0. All right, so notice what's in front of x and what's in front of y are equal. They're both 1 in this case, and the signs are the same. This is a circle. I will collect the x terms. X squared plus 3x plus y squared minus 2y. And I'm going to put it equal to 7. I'm just going to right away put that other number onto the other side. Now, I want to find out what goes in parentheses here. It's going to be x plus or minus something plus y plus or minus something. But what is that something? Well, I take half of whatever's in front of the x. Half of 3, I'll put 3 halves. I made one that's not so easy. So right away, half of that coefficient of x goes in the parentheses with x. So x plus 3 halves squared. And then what is 3 halves squared? Well, it's 9 fourths. 3 squared is 9. 2 squared is 4. And if I add 9 fourths to this side, I must add 9 fourths to the right side, to the other side. Same thing with this one. Half of negative 2 is negative 1. So this is y minus 1 squared. And then negative 1 squared is 1. And if I add 1 to the left side, I have to add 1 to the right side. And I'll add all these together. 4 times 7 is 28 plus 9. I need the same denominator. 4 times 1 is 4. So this is 32 41 fourths equals 41 fourths. And that would be the circle. The radius would be the square root of 41 fourths. The center is negative 3 halves. Positive 1 is the center. Because remember, it's x minus h squared plus y minus k squared equals r squared. So let me prove this by going to Desmos, if I can find Desmos. And what was the original? X squared plus y squared plus 3x minus 2y. Minus 2, 7, minus 7 equals 0. See, I've got a circle. And I will put my equation, x plus 3 halves squared plus, I think it was y minus 1 squared equals, what was this, 41 fourths. Same equation, see? So I completed the square. All right, so that's pretty simple one, other than I had a fraction to deal with. But sometimes they get a little more complicated. If it's an x one like this, if I have 3x squared plus 3y squared minus 2x plus 4y minus 7 equals 0. If I have that and I notice that the numbers are the same and the signs are the same, I would be better off, so now I know it's a circle, I'd be better off just dividing everything by 3. So this would be x squared plus y squared minus 2/3 x plus 4/3 y minus 7/3. I just divided everything by 3 equals 0, and then I go ahead. So, you know, that's when the signs are the same. I'm going to do one where it's different so I can show you how this works out sometimes. I'm going to do 3x squared, I'll do plus 4y squared, and I'll make this one easy. I'll put minus 6x minus 16y minus 7 equals 0. Okay, so now I'm going to collect my x's and y's and put the 7 on the other side. 3x squared minus 6x. I want them together. And then I'll put plus 4y squared minus 16y. And then I'll put equals 7. Now notice, the number in front of x and y have the same sign, but they're different numbers. Same sign, different numbers. A does not equal C. That's an ellipse. So now I will divide both of those terms by 3 so I can get x squared. Negative 6 divided by 3 is negative 2x. I get x squared by itself, and actually I should put a little bit more room in there like that. Plus, I'm going to divide both these terms by 4. Plus 4 times y squared, negative 16 divided by 4 is negative 4y. I'll leave room there, equals 7. So now half of negative 2 is negative 1. So I have x minus 1 squared, and I'll put the 3 in front of it. And then what's negative 1 squared? It's 1. Now I have to add, I added 1 to this side, but it's inside parentheses multiplied by 3. So 3 times 1 is 3. I have to add 3 to both sides, not just 1. Half of negative 4 is negative 2. So this is going to be plus 4 y minus 2 squared. Negative 2 squared is 4, and 4 times 4 is 16. So I have to do that. And then this equals 7, 8, 9, 10, 16 is 26. So remember, parabola, or I was going to say eclipse, ellipse is equals 1. So I divide both sides by 26. By the way, if you ever get something like this, where it's a positive number times x minus 1 squared, positive number times y minus 1 squared, and it equals some negative number, then there's no solution, because this would be positive, this would be positive, it can't equal a negative. So watch out for that. Sometimes they'll throw you a curveball. But so this one I divide by 26, divide by 26, divide by 26. So now it equals 1. And 3 goes into 3 once. 26 divided by 3, I don't think that comes out even. So, 3 divided by 3 is 1. 4 divided by 4 is 1. 26 divided by 4 is 13 halves. 3 times, 24. So that one doesn't get any easier or any simpler. So this is x minus 1 squared. You want to get rid of that number in front of it. So I divide top and bottom by 3 over 26 thirds plus y minus 2 squared over 13 halves equals 1. And that would be the ellipse. And let me type it into Desmos so you can see that it worked. 3x squared plus 4y squared, 4y squared, minus 6x, minus 16y, I think it was 16y, minus 7 equals 0. See, it's an ellipse. And now I will look at the equation I came with, x minus 1 squared divided by 26 thirds plus y minus 2 squared divided by 13 halves. And this better come out right. Equals 1. Same ellipse. So notice complete the square. So I showed you a simple one where you don't have to worry about any number in front of x and y, and a more complex one. You could, if you wanted to, I'll show this one another way. Let's see if I can just get rid of all this work. Here's another way to do this one. You could divide everything by 3. Well, see, you can't, because when you know this is an ellipse and these two are different, it's going to even make what's in front of y not equal to 1. So that's why you're better off separating them. When it's a circle, like I showed, if I had 3, I'll just give another example, 3x squared plus 3y squared minus 6x plus 2y minus 4 equals 0. If it's in a circle or a hyperbola where the numbers are the same, but either the signs are the same or different, then you could, in the beginning, just divide by, just make x equal to 1, and then, or what's in front of x squared equal 1, and then what's in front of y squared. This would be x squared. I'm just dividing everything by 3, minus y squared minus 2x plus 2 thirds y minus 4 thirds equals 0. So you could do that, and I know that this is a circle, so I could do it like that. Or even if it was minus, I know this is a hyperbola, and it still works out the same way, where I can just divide everything by 3. So you can either divide it all in front, if they're the same, if the number is the same but the signs are different, or the number is the same and the signs are the same, just divide it. Okay, let me find one example that's a hyperbola, and then I'll be done with this video. Sooner or later, have to be done. So how do I know it's a hyperbola? A and C have opposite signs. So I'm gonna do negative 3x squared plus 3y squared minus 2x plus, I don't want to make this super complicated. So I'm gonna do minus 6x plus 12y plus 7 equals 0. Okay. I don't want to make it too complicated. So I can collect my x's. Negative 3x squared minus 6x plus 3y squared plus 12y, and then put that 7 on the other side. Now I'm going to divide both of these by negative 3. Negative 3 divided by negative 3 is just 1, so x squared. Negative 6 divided by negative 3 is 2, plus 2x. And I'm going to leave a space there. And then I have to put a plus 3. And then 3y squared divided by 3 is just y squared. 12y divided by 3 is 4y. I'll leave a space for my squared number, minus 7. Okay, so I take half of 2, which is 1, and I'll put that with x plus 1 squared. I'll put my negative 3 in front of it. And now, 1 squared is 1. What do I put over here? Well, not just 1, it's negative 3 times 1. So I have to put a negative 3 to balance this. This 1 is balanced by negative 3 times 1 is negative 3. And likewise, this is going to be half of 4 is 2. So I have plus 3 times y plus 2 squared. And now 2 squared is 4, so I put that over here. 3 times 4 is 12, so I have to put that over there. Equals 12 minus 7 minus 3 is 12 minus 10 equals 2. All right, now I have to divide everything by 2 because I want this to equal 1. So I want to get rid of that negative 3. Negative 3 divided by negative 3 is 1, so that gives x plus 1 squared. 2 divided by negative 3 is negative 2 thirds. Well, I guess I'll put the minus over here, minus, and then 2 thirds. And then 3 divided by 3, 2 divided by 3 is 2 thirds, so plus y plus 2 squared divided by 2/3 equals 1. And then really, when I'm writing these, I want to put the positive term. I know that since the y squared component is the plus, it's going to look like this. So it's going to be y plus 2 squared over 2/3 minus x plus 1 squared over 2/3 equals 1. And let me double check just to make sure. Negative 3x squared plus 3y squared minus 6x plus 12y plus 7 equals 0. I get that hyperbola. And now if I write the one I figured out, y plus 2 squared over 2/3 minus x, was it plus 2? Plus 1 squared. That was also divided by 2/3 equals 1. Same hyperbola. So I showed kind of tough cases on that one. So there you go. That's how to do some completing the square to find circles, ellipses, hyperbolas. And then you can get the equations and look at, you have to memorize those tables of the features of them in order to figure out what the vertexes are, what the foci are, etc., what the asymptotes are for a hyperbola, etc. But you also have to remember this. When you have this equation, big AX squared plus big CY squared plus big DX plus EY plus big EY plus big F equals 0, it's a circle. If A and C are the same number, same sign. A equals C, they're the same number with the same sign. So 2x squared plus 2y squared equals 8. Or negative 2x squared minus 2y squared equals 8. Both are negative 2. They're equal and they have the same sign. I guess equal is enough. A equals C, they're making this difference with the same sign, but 2 equals 2. Negative 2 equals negative 2. So they just want to tell you the numbers are the same and the signs are the same. Ellipse, the numbers are not the same, but they do have the same sign. So 3 and 5, not 3 and negative. It couldn't be 3x squared minus 5y squared. That would be a hyperbola. And for hyperbolas, it's where A and C have opposite signs, even if they're the same number with opposite signs. So here's an example, x squared minus 9y squared. Or you could have negative x squared plus 9y squared equals 9, either way. If the x squared is the one that's positive, it's what's called horizontal. They open horizontally. If y squared is positive and x squared is negative, they open vertically. Sometimes you can't tell until the very end which one it's going to be. And then, of course, there's a parabola. Either y is squared or x is squared, and the other one is not squared. So that's it. Some completing the square along with how to tell a circle from an ellipse, from a hyperbola, from a parabola.